The air in the room 15 feet by 12 feet by 12 feet is 3% carbon monoxide. Starting at T equals 0, fresh air containing no carbon monoxide is blown into the room at a rate of 300 feet cube per minute. If the air in the room flows out through a vent at the same rate, when will the air in the room be 0.01% carbon monoxide? So let x of t be the amount of carbon monoxide, and this amount will be in feet cube, in cubic feet of carbon monoxide in the room at time t. So once again, we will set up the equation of the rate of flow of carbon monoxide. The net rate will be the inward rate minus the outward rate. However, in this case, since the incoming air is pure air with no carbon monoxide, so the rate of inflow of carbon monoxide is equal to 0 in this case. So rate of inflow of CO is equal to 0. So those of you who don't know chemistry, I'm pretty sure all of you know enough of it to know that CO is the formula for carbon monoxide. So rate of inflow is 0. So outflow, it's so the air is blowing into the room at 300 feet cube per minute, and it goes out at the same rate. So it's 300 feet cube per minute, but we want how much the carbon monoxide is. So first, let's note that the proportion of carbon monoxide in the room at time t will be x is the amount and the total volume x over v, where so x divided by v, where v is the volume of the room. So v is equal to 15 times 12 times 12. Okay, so 15 times 12 is 180, and 180 times 12 is 2160. Okay, so this much cubic feet. Okay, so that's the volume. So therefore, the proportion of carbon monoxide in the room at time t will be x divided by 2160. And now the air that's going out is 300 feet cube per minute. So the carbon monoxide in this 300 feet cube will be 300 times the proportion of carbon monoxide. So therefore, rate of outflow of carbon monoxide will be 300 is for the whole air, and x over 2160 is the proportion of carbon monoxide in that air at time t. So that will be equal to So 300, so the zeros cancel out, and 30 over 216. 65 times is 30, 636 times. So 5x by 36. 5x by 36. So now net rate, net flow, net rate of flow, CO equals inflow minus outflow, rate of inflow minus rate outflow. And now let's use equation editor. So net rate is dx by dt. Inflow is 0, outflow is 5x by 36. Now this one is really easy to do by separation of variables. Negative 5x by 36. Much easier to do separation of variables here. So bring the 5x down with the dx. So dx over 5x. Dx divided by 5x equals, and now on the right side you have negative. Actually, we could just do dx by x and leave all the constant on the right hand side. So negative 5 over 36 and bring the dt up. So negative 5 by 36 dt. So now integrate. This is separable now. Integrate both sides. So the integral of 1 over x dx is ln x. Ln x is equal to negative 5t, negative 5t by 36, so negative 5. Let's just ln x, so it should be ln of absolute x equals negative 5 t by 36, so negative 5 by 36 times t plus c. Okay, so now let's see what the initial condition is. So the initial condition is the initial amount of carbon monoxide. So the air is 3% carbon monoxide. So the volume, total volume is 2160. So initial amount of carbon monoxide equals, so it's 3% of the volume. So 3% of 2160. 2160 times 3%. Okay, so what is this? The zeros cancel out. 216 times 3 is 648. 648 by 10. 64.8. Cubic feet. So that is, so x of 0 is equal to 64.8. Now we substitute this initial condition here to get C. So X is 64.8, time is 0. So therefore C is ln 64.8. C is ln 64.8. So therefore this equation becomes ln 64.8. Let's just write it. ln 64.8. Now I can combine the two ln's. So bring this one on the left side because we like to solve this for x. So if I cut this from here, it gets subtracted on this side. Okay. And now you use log property. So this is ln x over 64.8. So now, since the next step is going to be raising it to the power of e, so whenever you do that, you know that e power anything is positive. So now, at this point, you don't have to worry about the absolute value. So x over 64.8. So now this gives you a taste of the fact that even a very simple separable equation, if you have to solve it for the independent variable, it gets very messy. And this one was so much easier because this part was 0 and this was just a straightforward expression, and this was even a constant. And yet how much work you can see we are doing to get the explicit expression for x. And you can imagine how much harder it would have been for the earlier problems, which were more complicated expressions, and therefore over there it would have been very messy to use separable method. Linear was the best over there. Here in this one it's about equal. So x over 64.8 would be e power, the right hand side. And so x will be 64.8 times this. X equals 64.8 times this. Okay. So the question was, when will the air be 0.01% carbon monoxide? So now this is the amount of carbon monoxide. So we can find the percentage of carbon monoxide. So that will be the amount divided by the volume. times 100. So basically, you will divide this by 2160 and multiply by 100. Divide this by 2160 and multiply by 100. So then this constant 6480 divided by 2160 will actually be 3. So 3 times this. So that's the percentage of carbon monoxide. So we want this percentage to be equal to 0.01. So we first divide by 3. Equals 0.01 by 3. Now take ln. So negative 5t by 36 equals ln 0.01 by 3. So you get the ln and then multiply by 36 and divide by negative 5. So t. So ln 0.01 by 3 times 36 divided by negative 5 equals 41.07. Okay, units. Okay, minutes. So this is 41.07 minutes. Okay.